Hello everyone. Today let me introduce to you a new lab which is called Circuit Simulation Lab. And in this lab we will deal with most of the electrical circuits and its theorems like Norton's theorem, Thevenin's theorem, superposition theorem, etc. And let's begin this with the simulation of Norton's theorem. Okay, so Norton's theorem states that any linear circuit containing several energy sources and resistances can be replaced by a single current source in parallel with a single resistor. Okay, so for simplicity, we will start with this circuit diagram, with this DC circuit diagram with the pure resistive elements, as you can see here, this one, and we are gonna simulate it using a software called Multisim. This Multisim, as I've already opened it, and we are gonna verify the result that we found out using this software with the analytical method. Okay, to begin with, let me redraw this same circuit diagram using this Multisim. For convenience, I've already done this, and we are going to find out the equivalent resistance, the Norton's current and voltage, etc. Okay, first let's find the value of the equivalent resistance without the voltage source. Here we have a DC voltage source of 10 volt, and we will remove it with a short circuit. Okay, we will replace all if there is any current source, then it will be replaced by an open circuit, and if there is voltage source, it will be replaced by a short circuit. Let me redraw this circuit without the voltage source. Okay, here is we have some resistors here. I'll just copy and paste it. Copy, paste, 1 2 3. Okay, so okay, this one. Okay, I'll just make the connection similar to the above, and from here you can make the connections like this. And then we will find the equivalent resistance for these three resistors. And after this, let's change the values. This one is 10 ohms. This is also 10 ohms, 10, and then this is 5 ohms, 5. And now we will need a multimeter. It is here on the top. I'll just put it here, and then here, and from here to here. Okay, so we're gonna find the equivalent resistance of these three resistors. Okay, so to do this, just double click this multimeter first, and then change to resistance mode, and then click run. Now we need to find the value of IN. So for this, I will make the connection like this, and we will need another multimeter here. IN means this one, this current IN. So to do this, we will need a multimeter again here, and then I'll make the connections here, and then from here to here. So similarly, I will do the simulate, and then here, and change the current to, okay, so the current is about 500 milliampere. You should note down the value of this. And now what we are going to do is we are going to calculate the value of this IN analytically. So to find Rn, you can use this one, R1, R2, R3. That is, first this R2 and R3 are in parallel, so R2 R3 by R2 plus R3 plus R1. This will give the the value of the equivalent resistance. Now let's find the value of IN analytically. So we have three resistances here, R1, R2 and R3, and let's call the equivalent resistance of these three resistors as R equivalent. So since R2 and R3 are in parallel, so 5 into 10 by 5 plus 10 plus R1 plus 10, this gives 13.33 ohms. So the equivalent resistance is 13.33 ohms, and this current I should be 10 volt divided by the equivalent resistance, which gives 0.75 ampere. To find the value of IN, we will need current division rules or CDR. So the formula says that IN equal to I into 10 divided by 5 plus 10. This will give the value of IN. See value say I huzik kanona calculator the whole lagi yenge see kya tage na I say 0.75 into 10 divided by 5 plus 10. Okay, this gives 0.5 ampere. 0.5 ampere means it is 500 milliampere. So earlier, using the software multisim, we found that the value of the value of the IN was 500 milliampere, and analytically we have also found that the value of IN is 0.5 ampere or 500 milliampere. So, and this will be the final circuit. A current source in parallel with a single resistance. Seen by Norton's theorem na haise. Current source amaga resistance amaga na any given circuit ki replace to yani hai bane ko. Yare aduna value ni se manaram ni na khoi experiment se chumme hai ba ko. Thank you.